Hi, everybody. I'm glad you're here with me today, and we're going to talk more about metric conversions and dimensional analysis. This is a little bit of a review, and we're going to go into some of the why. Why do we do this way? So, we're going to talk about building the clinical foundation of why we do things and help you to develop a reliable blueprint for metric units and dimensional analysis in your nursing practice. On the screen before you, you can see the top image is what the United States looks like from space at nighttime. That's the eastern seaboard, and you can see all those lights that light up the eastern seaboard. In the second image below, you see what happened after Hurricane Helene hit, and you can see a huge dark swath going from the top of Florida all the way to the top of North Carolina. That's showing you where there's no power. So now think about it. How many hospitals were in that pathway? And no, they didn't have generators. They got washed out in the hurricane. Do those hospitals keep functioning? Yeah, we're mandatory, essential employees. We have to be there. People have to be taken care of no matter what's going on. I worked through Hurricane Sandy. You have to go and take care of people where they're at, and you have to do the best you can in that given situation. So now I want you to think about something else. So many of you have flown in an airplane, right? So the pilot is taught how to fly that plane. But 90% of the time, the plane is flying on autopilot, meaning that the computer is flying the plane. But if something happens, would you feel better if the pilot actually knew how to fly the plane when something happens? If they don't know how to fly the plane, then everybody's going to crash on that plane, right? And that's going to impact everybody's safety in a big way. So, as a nurse, we use autopilot in our practice in the United States because we have beautiful tools that are all computerized that take a lot of the guesswork out of what we're doing. But in situations like this, like Hurricane Helene, when power is lost to a huge track, nobody's getting power anytime soon. You need to know how to practice as a nurse without electricity. There won't be any electricity for your pump, for your IV, so you're going to have to do manual drips. There won't be a Pyxis machine. There won't be electronic pharmacy sending you stuff. Everybody has to go back to manual work to do this. So you need to know how to be a safe nurse no matter what happens. That's why we teach you how to do your medication calculations. And part of that is having predictable systems that support patient well being. In your clinical practice, every nurse must speak the exact same measurement language. And that's why you need to have your conversion factors memorized. For next week's quiz, you won't be allowed to use your conversion factor cards. You need to have it memorized by then. So this week, you're going to have a worksheet that covers metric conversions. There's 10 questions. And you need to pay attention to those and use it as an opportunity to really build your skill with knowing your metric conversions. So, what does dimensional analysis provide to us? It gives us uniformity. Every nursing student and nurse converting units the same way ensures consistency. It provides precision. Structured math prevents underdosing and overdosing. And it gives you confidence. A reliable framework allows you to focus on the patient, not the arithmetic. So there's two pillars for clinical measurement. There's weight and volume. The base unit for weight is grams, and the base unit for volume is liter. For grams, you're looking at micrograms, milligrams, and grams. For liters, you're looking at milliliters and liters. Try to keep in mind the step system for the rule of 1,000. So 1 gram is your foundation. There's 1,000 milligrams in every 1 gram, and there's 1 millionth of a gram in every for the micrograms in every gram. Notice that clinical weight operates in perfect increments of 1,000. There are 1,000 micrograms in 1 milligram and 1,000 milligrams in 1 gram. Just having that in your brain will help you in a stressful situation trying to figure out what comes next. Dimensional analysis is your blueprint for how to get from one place to another. Knowing the destination, what unit is the question requesting? This is always where we start building. That's what's placed to the left of your equal sign. Next, it's not always in the second position, but oftentimes it is the bridge. That's your conversion factor that safely links the units. You're not always going to be given a conversion factor in your problem, and you'll know if you can't get from point A to point B, it's because you need a conversion factor. That's the missing puzzle piece that you have to know which conversion factor fits this puzzle at this place. And the clinical dose or value given that the provider ordered. Safe crossing, that's your conversion bridge. Your conversion factors are your bridge that get you from one point to another. A conversion factor is that bridge because the top and bottom of the fraction represents the exact same physical amount of medication. Crossing the bridge translates the unit of measure without altering that dose. So you building a dimensional analysis puzzle, it self-corrects. Dimensional analysis acts as a built-in safety check. When you align your starting point and your bridge correctly, matching the units on the top and bottom crisscross ways just naturally dissolve. Everything just naturally cancels out, and you should be left with what you're looking for. Remember how to construct your equation. You need to know what is my question. So in this particular scenario, you are asked to convert 0.025 grams into milligrams. So it's asking for milligrams. So milligrams goes in the numerator position to the left of the equal sign. And milligrams is going to go in the numerator position to the right of the equal sign. So we can't get to grams without a conversion factor. That's your bridge. So 1,000 milligrams, because you have milligrams on top, is in 1 gram. See how you can flip those? It's mathematically correct to flip them. Now you have grams on the bottom, and your question asked you 0.025 grams. So that's going to go on the top of the next fraction so that you can cross-cancel those units of measure out. Cross out gram, you're left with milligrams, which is what you want. Now all you have to do is the math. 1,000 times 0.025, and 1 times 1 is 1. 1 divided into that is going to give you 25 what? 25 milligram, because milligrams is the only value unit of measure left standing. So then you have to ask yourself, does it make sense? The final step of any dimensional analysis is to step back and see, does this make sense to me? Going through your reasoning, if it doesn't make sense, find somebody who can help it make sense to you. And that's not another student nurse. It has to be a nursing instructor, a nurse, a preceptor, somebody with more experience than you who will help sort it out and make sure that you have the correct thing. Here are some examples of how to do this. This is just a repeat of what we've already gone through. So you can pause here if you wanted to go through and see how the units of measure match up and how we got the answer to the problem. I'm hopeful that by this point, most of you seem to be doing extremely well on your worksheets. So if you do struggle, if you have any problems, please reach out to us. All right, this amoxicillin and the following cefazolin are covered in the next video, so I'm going to leave those and they'll go over them in that video. And just to go over the 4 pillars, moving from theoretical math to hands-on safe practice requires methodological execution. I knew I was going to mess that up. Read the label. Confirm the baseline unit supplied by the pharmacy. Convert units. Use the dimensional bridge to align the order with what you have in supply. Determine volume dose. Calculate the physical amount to draw up or administer. Document safely what you just did. What did you draw up? How did you get what you got? And what did you actually give to the patient? This impacts the entire system. System-wide accurate conversions. Unit conversion is not an isolated academic exercise. It is the linchpin of clinical communication. Accurate unit conversion impacts MAR documentation, that's medication administration record. Proper conversions ensure the dose documented perfectly matches the provider's intent, preventing transcription error. Accurate unit conversion helps with medication reconciliation. Accurate unit tracking allows safe continuity of care when patients transfer between units or levels of care where the medication concentrations might be different. This is a foundation you can trust. By replacing guesswork with the structured blueprint of dimensional analysis, you ensure a safe translation between the provider's order and the patient's actual dose. A reliable method creates a calm, confident nurse and supports optimal patient well-being every single time. Thank you for listening.